Welcome, everybody. Thank you for taking the time to join us today. We're excited to be continuing a discussion on inventory optimization strategies. This webinar will be the second part of our three-part webinar series on the 3 must-have inventory management software features. Today's presentation will focus on safety stock optimization. Again, my name is Helen Utiavo. I'm the marketing manager at Arkieva, and I will be moderating this webinar. Once again, I'm excited to have with me Arkieva COO Sujit Singh, who will be continuing the discussion on optimizing your safety stocks.
Hello, everybody.
Before we get started, I'd like to mention that if at any point in time you have trouble hearing us, please let us know using the chat feature in GoToWebinar, and we'll be sure to assist you. Also, we'll reserve a few minutes at the end of the webinar for questions. Feel free to answer your questions as you think of them using the questions window in GoToWebinar. So to start off our discussion on safety stock optimization, I kind of wanted to open it up with this question on what's the opportunity cost of a stock out? You know, a stock out is something that as manufacturers we want to avoid because it often comes with unfavorable effects or consequences. Stock outs cause a reduction in cash margin. It leads to us having to ship things in a speedy way so that we can get things to the right place on time. And for those of us in the B2B world, it can lead to you having a situation where you're jeopardizing your contracts with certain business relationships that you have. So at the end of the day, we can all agree that stock outs are something that we want to avoid. If you're more in the public space as well, you might experience something with your stock prices, or you may cause a reduction in your brand value. So while we want to avoid stock outs, we also don't want to hold excess inventory. So how do you keep the right amount of inventory so that you can have the right size inventory? That's the question that we're trying to address today. So let's look at the agenda for today. We talked about the 3 must-have inventory software features in our first presentation. We discussed inventory visibility, analytics, and policy setting. Today, we're going to focus more on inventory optimization and focusing more on safety stock, which is going to be the focus for today. And then our next webinar is going to talk about planning and reporting. And some of the things that we're going to discuss are some of the 5 main reasons to hold inventory. So Sujit is going to talk about some cycle stock, safety stock, anticipation, in-process, and transit stock. And then we're going to look at if you should optimize your inventory, looking at it from multi-echelon versus single echelon. So as usual, we just want to give a little introduction about who we are as a company. We've been in business since 1993. We have a single supply chain focus. So what that means is that all the strategies that we're going to talk about today is embedded in our solutions. We have a full suite end-to-end solution that does everything from demand management all the way to helping you manage your end-to-end supply chain. Our solutions are also tightly integrated, which means it's very easy to scale up and down as you see, please. And it's built on the Microsoft platform, which essentially makes it very easy to integrate as well. So now that we've covered a little bit on the introduction, I think I'm going to turn it over to Sujit, who will talk about the Arkieva inventory optimization process. Sujit?
Thank you, Helen. All right, so as Helen pointed out, at Arkieva, we believe in a 3-step process towards optimizing the inventory. In our part 1, we talked about inventory analytics. And in that discussion, we looked at how to make something as make to stock and make to order and assemble to order. We looked at things like 9-cell analysis. We looked at ideas around rebalancing across locations, across packages, and so on. Today, we'll be focused on the safety stock, and we'll look at both the single and the multi-echelon way of thinking. And in the next session, we will get into the time-phased planning of the inventory, and that will conclude our three-part session. So let's jump right in and look at today's topic, which is around safety stocks. So before we get there, let's talk about the different types of inventories that people hold within their supply chain. There are 5 main areas that I can think of. We'll get through these in some amount of detail, so let me just list them really quickly. We might have strategic stock, we might have in-transit or in-process stock, we might have some anticipation stock in terms of building something up to foresee the lack of balance between supply and we might have some safety stocks to absorb any kind of variability in demand and as well as in supply. And then, of course, we'll have some cycle stock to cover for any kind of cycles that we might have in our production or in our ordering process. So let's look at first let's look at strategic stock. So what is strategic stock? Strategic stock is stock that is kept for strategic reasons, as the name suggests, such as anticipation to price evolutions, anticipations to change of suppliers, maybe to identify supply risks or opportunities. So if you, for example, anticipate that the entire market is going to change, the oil prices are going to go up, well, you might hold a strategic reserve of oil as strategic stock. One thing to keep in mind as we talk about strategic stock is that risk does not mean the same as variability. So variability is just up and down of demand or supply that happens in due course, in natural course. Risk is, a little bit more refined, where we are worried about something just disappearing entirely, for example, or for that matter, having too much of demand. How's this strategic stock plan? Well, typically in organizations, there are sales and operations planning teams. They decide the strategic stock based on various factors. For example, they might be looking at a particular risk or an opportunity, and they might place some importance on it, and that will then drive how much safety stock to carry. They might actually be looking at the probability of a risk of an opportunity. If the probability is very low, they might not want to keep any such strategic stock around that. And of course, in any planning decision, they have to look at the impact of the do-nothing option. So what if, or even the do-something option. So what if they hold the safety stock, the strategic stock, and the estimated risk or the opportunity just does not take place? In that case, well, you have a situation where you made the wrong decision. So what is that impact? All these are factors that can go into the planning of the strategic stock. Here's an example. Companies that make vaccines for some very rare diseases, they might have to keep some strategic stock just in case of an unforeseen epidemic. Every once in a while it does happen, and if they just go by the average use case, they might not have enough stock ready when there's a real need in their marketplace. So they might have to carry some strategic stock as just in case. Next is the in-process or in-transit stock. So as the name suggests, this is the stock that exists because things are going on and they take a certain time, and during that time we hold inventories. So as an example, the production process could be long or the transportation process could be long. If that takes weeks, if it takes weeks to get product, let's say from Asia to North America, well, in that time the inventory that is sitting on a boat is in-transit inventory. A very simple way to calculate the in-process or in-transit inventory is to look at the average demand and multiply it by the process lead time. So it's a very simple formula. Now, as one observes the in-transit or in-process inventory, if one sees that stock is rising, there are 2 main areas since the formula is so simple. One could be that your sales might be increasing. And if that's the case, well, you should take every possible advantage of the situation because sales are really independent to what you do. On the other hand, it might be the case that your goods are staying longer in the production or in transit process. Now, this can then immediately become an area of improvement. You might want to bring things under control, and you can do that both on the production side as well as on the transit side, so as to reduce the total lead time, not just one component of the lead time. An example of in-process or in-transit inventory could be stock that is sitting in an oil tanker on the way to the destination. So if the oil tanker is going to be traveling for 3 weeks, well, that's your in-transit inventory over those 3 weeks. Let's look at a couple techniques around in-process inventory reduction. One is, of course, you can look at reducing the production lead time. There are certain physical techniques available to us. So if you invest in lean manufacturing techniques, you might be able to accelerate the flow. You accelerate the flow, your inventory goes down because your production lead time goes down. If you have certain bottlenecks, well, there will be inventory that will sit in front of it, that will slow everything down. So another physical technique to improve in-process inventory situation would be to increase your bottleneck capacity, which will allow the inventory to flow through that bottleneck point much more freely. You might be able to take a resource, do some work on it, make it more flexible. If it is more flexible, then it can handle different kinds of productions. If it is able to do that, well, then you have more flexibility, allowing you to process more inventory through, which will again have a reduction in the in-process inventory. There are certain planning techniques on top of the physical techniques that we just talked about. So if you are interested in those, you might actually be able to do better job of production scheduling. You might have to invest in certain technologies, but you might be able to do a better job. And if you do that, you might be able to align the different operations in a way that overall flow is accelerated. You might also be able to look at your bottleneck resources. And if you really think that the bottleneck resources cannot be expanded, the capacity on them cannot be improved, then you might have to do your planning in a way that makes the most effective use of those bottleneck resources. You do that, your flow increases, your production lead times go down. Now, one nice thing about reducing production lead time is that it does not only impact the in-transit stock here that we are discussing, it can also increase customer satisfaction, because these days customers are more demanding. If we can reduce the lead time from 7 days to 6 days, they are happy. So we want to do that. Also, the production lead time is a direct factor in the safety stock calculation, as we will see a little bit later. So it can also have an impact in the safety stock numbers as well. Next, let's briefly look at anticipation stock. As the name suggests, it is the stock that is being built in anticipation of a future imbalance between supply and demand. So, if you are, for example, in the business of selling air conditioners, well, summer is when you really sell the air conditioning units, but you might have to build the stock in wintertime because you know that the demand in the summer months is going to be more than the supply that you can create. So you build this stock in anticipation of those months, of those extra or heavy demand months. How is the anticipation stock planned? Well, the obvious answer is that the production scheduling team and the sales and operations planning teams, they decide the buildup of how much anticipation stock they would like to have. And they are really looking at the imbalance between the demand and the supply, and they are also looking at their own strategy. Are they a level production versus a chase production strategy? And if they are following one versus the other, they might have to make the anticipation stock. In general, if you are able to follow the chase production strategy, in other words, you are chasing the demand, you're making it as late as possible, in that case, you might not have to do any anticipation stock. If you're trying to level load your plants, well, in that case, you will have to build some anticipation stock. And of course, they will be looking at things like the target inventory at the end of the imbalance. So, if there's a heavy demand period, where do you want the inventory to end up at the end of that demand period, as well as how much is the budgeted allocation in the front of that heavy demand period, so that you do not have too much, so that you don't get the management team all upset about how much inventory you are carrying. Companies can obviously look at the demand picture. They can also look at the supply picture to figure out that there is going to be an imbalance. So if they know that their supplier will not be able to satisfy the future demand, they might then go ahead and build some anticipation stock. So it's just a different way of looking at that imbalance. You can have a demand-driven imbalance, as well as you can have a supply-driven imbalance. Next, let's look at the cycle stock. Again, very briefly, we'll go through the definition. So the idea of cycle stock is, as the name suggests, it's the amount of inventory to cover the time lag between cycles. So let's look at the picture here. You might have a buying cycle, you might have a shipping cycle, you might have a manufacturing cycle. If your manufacturing cycle is such that you make the same product every 30 days, well, in that case, you must make enough in one production run to last you through that next 30-day cycle. So the calculation of cycle stock is also very straightforward. It's basically average daily demands times the cycle time divided by 2. The divided by 2 simply takes into account the factor that when you end your production run, you will be at a peak point. By the time you're ready to make the next production run, you will be at the lowest point. The average between those high points and the low points is simply the number that is divided by 2. So that's how you get to the average cycle stock. Very straightforward. Next, let's look at safety stock, which is where we'll spend most of the time in the webinar today. So safety stock is the amount of stock that we keep to protect ourselves against uncertainties or variabilities in demand and supply up to a desired customer service level. What do we mean by a customer service level? Well, when we have a customer, they have certain expectations. For example, your customer might have an expectation, especially if you are in the retail business, that when they walk in the store, they will have the product available. If you're in the B2B business, the expectation might be that when they call and say, I need the product 7 days from today, that you will be able to provide that product in 7 days' time. The service level is the idea that what percentage of time I am, or as a company, we are able to meet the requirements as expressed by the customer. So there are multiple ways of measuring service levels. One is very popular one is called the cycle service level, especially for companies that are dealing with cycles. This for retail chain, that could be a daily cycle to restock the shelves. For some other companies, it could be weekly or a monthly cycle. The key question in the cycle service level is, what percentage of my replenishment cycle is it acceptable to have a stock out in? So if I'm willing to accept 2% of my cycles to have a stock out, then I'm aiming for a 98% service level. If I'm willing to accept a 5% stock out, then I'm aiming for a 95% service level. This is particularly useful in retail stores or really in any environment where we do not have a view of the future demand of the customer. So if you are not in the process of recording what we call open orders, then the cycle service level is the way to go. The fill rate based service level, on the other hand, is based on the idea that what percentage of the orders are available to be shipped directly out of inventory. So let's take an example. If a customer calls looking for 1,000 units of product and you have 800 units in stock and you are able to give 800 units to that customer right then and there, then by the fill rate way of calculation, you have just achieved 80% service. By the cycle way of thinking, because you are going to have a stock out as soon as you give the customer those 800 units, you have just achieved a 0% service in that cycle because you have a stock out. So depending on the business you are in, you might have to choose the appropriate service level. Service levels are represented and are an important factor in the calculation of safety stock, and they are represented by a multiplier. Sometimes you call it the K factor, sometimes you call it the Z factor. and it's a very easy thing to calculate. Here's a table that kind of gives you an idea. At 50% service level, so if you want to, for every 2 orders, you're willing to have one being supplied and one being stock out, which is a very poor service level. So at 50% service level, really, you do not need any safety stock. The K factor happens to be 0. By contrast, at 90%, it's 1.28, and 99.9%, it's 3.72, which is roughly 3 times the number at the 90%. So to achieve the 99.9% service level, you need 3 times the safety stock that you need to achieve the 90% service level. In fact, this curve approaches infinity. So if someone says, I want to have 100% service level, theoretically at least, the K factor will be infinity, and in a way, you can say that that is unachievable. Every once in a while, we will miss certain orders, because the amount of inventory you will have to keep to make sure you meet every order exactly on time is infinite. Right. So let's look at the safety stock calculation in a little bit more detail. And let's start from a picture where we are only focused on variability in demand. Remember, I said earlier, safety stock deals with both demand and supply variability. Well, let's look at this picture here. And you will see here, there's a line that represents the average demand. So this average demand could be an idea where we look at last 12 months and we average it out and we say this is the expected demand as it pertains to this particular supply chain. Well, it is possible that in any given period, the demand might come in below average, which is represented by the line above, or above average. If it comes below average, well, let's first look at the average demand. So if the demand comes at the average, well, then we would, if we started with this much starting inventory, which is on the left-hand side here, well, we will end up with this dotted line. That's how much inventory will be left in the system. If, on the other hand, we have a below average demand, well, then we will consume the product at a much slower rate. We will be ending up with a lot more inventory. On the other hand, if we have an above average demand, which is this line at the bottom, well, surely we will be hitting the negative territory, which means we will have stockouts. So in this way of looking at the safety stock, where we are only concerning ourselves with the variability in the demand, really the lead time is less of a factor. We are just worried about whether the demand shows up, at what rate does the demand show up, and if that rate is going to push us into the negative territory, the stock out territory. Now, in the previous slide, when we said average demand, we are using average as some kind of a predictor of the future demand. So not knowing anything else, we are saying the future demand equals some kind of average from the past. Well, these days, a lot of companies invest a lot of time and effort into forecasting processes. So what if you are one of those who believe in forecasting, who actually have a forecasting process? Well, in that case, the same graph can apply. Instead of the average demand as the expectation, now your expectation is the forecast, and then there's every possibility, just like the average demand, that your sales might be lower or higher than the forecast, resulting in very similar types of situations. If you have lower than forecasted sales, you will have too much inventory. If you have higher than forecasted sales, you might run out of the inventory. Now, a quick word about the normal distribution or the bell curve distribution you are seeing here. The width of this and how much of this we want to cover is driven by the service level, the concept of service level. If we have a very high service level, we will basically carry enough safety stock to cover a lot more of this bell curve. If we have a low service level, we'll have less safety stock to cover for that variability. In fact, the 50% service level corresponds right with that dashed line, which is in the middle of that normal distribution. So that means that if we were trying to keep 50% service, as soon as even 1 unit of extra demand above the forecast would show up, we would run out of inventory. We would go to a negative inventory position. Now, is it advantageous to use the forecast or use the average demand? Well, the answer is, if you are running your business by the forecast, you really do not have a choice. You should then calculate your safety stock through the use of the forecast numbers, because then you are if you use the average demand, you're using the wrong expected value out in the future, because your entire planning is revolving around this forecasting process. So in this case, what you want to do is, when you calculate things like standard deviations and so on, you want to calculate around the forecast error and not so much around the error against the average demand. What happens to the safety stock if you happen to be the company that forecasts perfectly, or if you are the person who does so? Well, I mean, one obvious answer is you are in the wrong job. You should probably look for jobs where you can have a lot more money forecasting perfectly. But jokes aside, as far as the safety stock need is concerned, if you are forecasting perfectly, that means you have the right product at the right time. You do not, at least theoretically, need any safety stocks. On the other hand, if you are also a company that is not so perfect, but you're consistently over forecasting, well, in that case as well, you're planning for too much product. You will probably have too much product sitting on the shelves. So again, the case can be made, you do not really need safety stock, or at least you need a lot less of it. Now let's, having looked at the demand variability, now let us bring in the concept of lead time or the supply variability. So now in this graphic, everything is the same, except at the bottom here, we are saying what is the average lead time expected and what is the variability around it. Again, I put a normal curve down here to show the variability of the lead time. So what is the meaning of that? Well, the meaning is that the lead time from point A to point B on average is 10 days, but sometimes it can take 9 days, sometimes it can take 8 days, sometimes it can take 7 days. And by contrast, it can be slow as well, and sometimes it can take 11, 12, 13, 14, 15 days. So the idea of finding an average and a distribution around it gives us this concept of variability. And then, as you can imagine, if the vehicle that is bringing the product in is running slow, now you need some extra inventory to cover for those extra days that it will take for the product to arrive. So again, just like the speed of the demand, the variability in the lead time has a very similar effect. If it is running faster, well, you will not run out of the product. If it is running slower, you will run out of the product, and therefore you will need safety stock. So we'll look at a couple formulas, not to bore you with math here, but just because on the formulas you will see these notations. We'll use mu and sigma. I don't want to spend too much time on it, but mu is shorthand for average, so just your simple average. And if we use the letter L after it, then we are talking about lead time. If we use the letter D after it, we are using it for demand. Sigma is standard deviation. Again, D and L have the same meaning, demand and lead time. Sigma squared is variance. So these are sigma and sigma squared measure the variability, mu measures the average. So if with that knowledge, let's look at the actual safety stock formula. And if we look at the safety stock formula, which is right there in the middle of the screen, it is K, which is the factor that I talked about that comes from the service level. Remember that 50% has a 0 factor and 99.9% has a very high factor, 3.72. So K is that factor, and then we have a square root, and inside the square root we have two terms. The first term deals with the average lead time times the demand variance. So this is the term, it's important to understand, even though you don't remember the formula, this is the term that deals with the variability in the demand. And the second term is average of demand times the lead time variance. So this is the second term deals with the variability in the lead time or in the supply. Now, as we will see in a few slides, this knowledge can really help you determine your safety stock strategy and the supply chain strategy, really, if you had certain situations going on. So again, even if you don't remember the formula, just remember there are two terms. The first term deals with the average lead time times the variance of the demand. So the first term deals with the variations in the demand. The second term deals with the variations in the supply or the lead time. So let's take the case where a company is so lucky they have 0 lead time variability, either that or they do not have the data related to the lead time variability, and they are forced to only look at demand variability. Well, in that case, the basic safety stock model, the second term disappears because they do not have the lead time variability, and it basically simplifies itself to K times this term here. And remember, the sigma squared is the variability in the demand. So you can simplify, if you don't have all the data, if you don't have the lead time variability data, you can simplify it and you can just use a much simpler version of the formula. If, on the other hand, you are in a business where the lead time variability data is available, but demand variability is not available, which is rather rare, but it's, I guess, theoretically possible. Certainly, it's possible that the lead time variability is way more important than the demand variability. In that case, the safety stock model will simplify itself to just including the second term. So in this case, K times the square root of the second term. Now, let's look at a few special cases. What to do if you have a planning cycle, which is, which represents a lot of the company. So if you have a planning cycle of 30 days, well, now, yes, you could get the safety stock in whatever the lead time is. So let's say lead time for a particular product is only 3 days. You can get that product in 3 days, but because of the cycle involved, sometimes you will have to wait a full 33 days in order to get that product. So in that case, your safety stock calculation will need to be adjusted, and your lead time in that calculation will need to be adjusted or incremented by the number of days in that cycle. So if your lead time is 3 days and cycle is 30 days, you might have to implement a safety stock formula that uses the lead time of 33 days. Now, these are theoretical suggestions. Of course, in due practice, you might actually have a way to break into the schedule if that happens, and therefore you might not need the full 30 days. But in general, it will have an increasing effect on your lead time. If your customers are so kind that they always provide you an order lead time, so when they call you, they don't want the product then and there, unlike the retail store, where when I walk in, I need that piece of soap, a bar of soap right there. If I'm willing to call ahead, place an order, and then collect it 7 days later, well, that creates this concept of an order lead time. And if there's an order lead time, then your average lead time in the safety stock calculation which can be decremented by that order lead time. Because in one way, you do not have to carry the inventory for 7 days because the customer is consistently giving you a 7-day lead time. So these are some modifications that you can do to your safety stock thinking. If both of the above are happening, meaning you have a cycle and the customer is also willing to give you a lead time, then the average lead time will be incremented by T minus S, in which case the T is the cycle time and S is the customer order lead time. If it so happens that your customer order lead time is more than the supply lead time, well, guess what? You don't need to carry any safety stock because your customer is willing to wait longer than what it takes for you to procure the product. In that case, you are in a true make-to-order environment. Right, so just another glance at the formula. I don't intend to spend a whole lot of time here, but if you have the basic formula, we use the mu L, which is the average lead time. If you have a cyclic planning, you increment the mu L with the cycle. If you have a customer order lead time, you take that mu L, which is the average lead time, add the cycle plus T, subtract the order lead time, which is minus S. So these formulas can be tweaked based on the situation we find ourselves in. In fact, every company might have all three situations going on. And in that case, for one product, you might use one formula. For a different product, you might use a different formula. Now, sometimes people will ask us what to do if my supplier is unreliable on quantity. So I order 1,000, sometimes I get 900, sometimes I get 1,100. What can I factor for that? Well, yes, the formula is such that you can, inside that square root, you can add more terms. And so you can add a term for supply quantity variability. If the supplier is unreliable on quality, you can add a term for supply quality variability as well. In fact, there is no limit. You can keep adding. And the math might get a little bit more cumbersome, but you can certainly keep adding. However, what we have found is that in practice, companies simply do not know how to measure the variability on the quantity and the quality. They do not have the right data. And so what they typically do is just increase the lead time, the average lead time, or the variability of the lead time to keep things simple. But you can certainly add more terms to your formula. So let's now try to conclude this discussion on safety stock. So safety stock formula is K times the square root of multiple factors. Typical usage, there are two terms, two factors. One is demand variability related, one is the supply lead time variability related. But in advanced formula versions, you can actually add quantity variability and quality variability related terms as well. Okay, now let's look at, we talked about safety stock, we talked a lot about demand variability and lead time variability. Let's now dive into those a little bit. So we are looking at demand variability, and the question is, how can one manage demand variability? Well, the simple answer is demand is typically driven from the market, outside sources. It's an independent input, almost impossible to control. You might be able to do some amount of demand shaping and those types of techniques, but in general, it's an independent input and difficult to control. So in that case, what can you do? Well, you can invest in a forecasting process, and if you do it well, you will be able to predict where the demand is going. If you do that, you will be able to reduce the variability. So if you have a forecasting process, you can use the error in the forecast as your variability measure. And hopefully it is better than just using the average. Otherwise, your forecasting process is not really doing a whole lot of good for you. Lead time. So what is lead time? Well, lead time is the time it takes from when we have the need and when the product becomes available. So imagine a situation, you have a zero stock of a particular product, customer comes in and says, I need this product. How much time will it take for you to get that product in? If you're a manufacturer, that will mean making it from scratch. If you are a distributor, that might mean buying it from your supplier. However your supply works, what is the total lead time that exists between the creation of the need and the availability of the product? Now, this can be driven by multiple factors. You might have planning and supply cycles. We just talked about that. Your supply process will certainly have a control on that. Transportation, if you're getting it from Asia into North America, that will be a longer lead time, and so on. Handling external versus internal can have an impact. Anyone who does international business, sometimes you have to add an average of 5 days just because it has to go through a customs process. So all of these things add into the lead time, and you need to be aware of that, and you need to be aware of the variability that exists inside this lead time data. So if we have a lead time situation going on, how can we improve the safety stock or decrease the safety stock that comes from the variability in the lead time? So as you look at the formula at the bottom of your screen, you will see there are two terms. I'm back to those two terms, and I'm pointing the arrow at the first term. The first term, if you will recall, deals with the variability in the demand, that's the sigma, and the average lead time, that's the mu. So if your demand is highly variable, it's uncertain, it goes up and down all the time, guess what? Sigma related to demand will be a big number. If that's a big number, multiplying that by the average lead time will make that term very, very strong in this calculation. So if you look at the schematic here, if you have a very uncertain or a highly variable demand, you can see the overall safety stock increases at a very fast pace as the lead time goes up from 2 days to 20 days. And if that were the case, if you find yourself in that situation where the demand is very highly variable, the thing to do is to work on reducing the average lead time. So how can you do that? Well, you might be able to position the stock closer to the customer. You might create strategic buffers so that you can break the chain. You might have these decoupling points so that you have some buffers to allow you to reduce the lead time. You might be able to find a supplier who is closer in distance, therefore closer in time, thereby reducing the average lead time. So if your demand is variable, a key action step would be to work on reducing the average lead time. How to measure if your demand is variable? One way to measure that is the coefficient of variability, which is a very simple calculation, standard deviation divided by mean. Depending on the business you are in, anything more than 0.3 could mean highly variable. So if that is the case you find yourself in, again, the thing to do is to focus on reducing the average lead times. Again, in any company, you might have a mix of both. What's the other part you might have? The other part might be where the average is strong, so you have a high volume item, but the variability is low. Well, so if it's a stable product with high average, guess what? It might be better for you to accept a longer lead time as long as you can make it more reliable. Why is that? Because now we are dealing with the second term in the safety stock formula. This deals with the sigma on the lead time, which is the variability on the lead time. So if your mu, or the average of the demand, is strong, in other words, this is a high volume item, you don't want the variability of the lead time to be very high, because then it will skew your safety stock numbers and make it really bad. So for those items where the average demand is strong, you might want to focus on getting the lead time variability down, even at the expense of a higher or a longer lead time. Now, in practice, while we talk about these as separate cases, everything is intertwined, so it is always good to reduce both the average lead time as well as the variability. But I wanted to at least give you some idea around when it might be profitable or beneficial to focus on one versus the other. Let's look at a couple questions that get asked about safety stock quite often. One is around days of supply. This seems to be a very popular way of mentioning the safety stock, and the question is, should we do that? Our general advice is no. One reason is that people have done some research. Days of supply-based safety stock methods typically result in 30% more safety stock. But it also creates what is called the bullwhip effect. The bullwhip effect simply says that as changes are made in the closer to the customer in your supply chain, it has an impact. You are making more and more away from the customer. Well, if you have a days of supply-based safety stock, it creates its own bullwhip effect, because as demand goes up, safety stock goes up as well. Thereby, it creates a need for even more product. So you have to make more for the demand, but you also have to make more for the safety stock. It just becomes a very bad cycle and creates this bullwhip effect. So our general advice is to avoid that. Another question is, how often should one change safety stock targets? Well, the obvious answer is only as often as you can execute the change. If you have a computer and it can spew out new numbers every night, are you really going to be able to go to the warehouse and make that change effective? If the answer is not, then really that change is not worth anything. In fact, in our practice, we have seen that once a quarter or once a 6 month is what most organizations can manage by way of changing their safety stock targets. So that can be a good frequency with which you want to manage and maintain the safety stock changes. All right, so far we have discussed the idea of calculating the safety stock in a single echelon way, which is a node and a product at that node, a location and the product at that location. Now we'll look at the multi-echelon approach, which deals with this idea that there are multiple layers in the supply chain, and the question is, where should we carry the inventory? So let's spend a few minutes on that. Let me share some research with you. People have conducted this research, Aberdeen and Dr. Desmet from Solventure, and published these papers where we find out that if you use rule of thumb based methods, things like a flat target or a days of supply based target, compared that to the single echelon methods that we just discussed, there is about 20 to 30% savings. If you take that to the next level and do multi-echelon inventory optimization, which is something we'll look at next, there's a 20 to 30% savings. If you are so lucky that you can actually work with your suppliers as well as your customers and do the extended MEI that stretches across these organizations, well, guess what? You can have another 20 to 30% savings. So these steps are a part of the evolution of the inventory strategy. Most companies begin with rule of thumb methods, go to the single echelon, get some benefits, go to the multi-echelon, get more benefits, and so on. So we'll look at the multi-echelon way of looking at the forecast now. So here's an example network. This is a fictitious ketchup company. On the right-hand side is the customer who buys from a store, who gets the product from a warehouse, who gets it from a plant, and at the plant we have a network around the bill of materials. So there are two distinct networks here. One is the distribution network, and one is the manufacturing or the bill of materials-based network. So in the multi-echelon thinking, one of the first things we do is we ask the question, how many echelons are there? So the stock facing the customer is one echelon, one step removed is the second echelon, one step further removed is the third echelon. And depending on the business you are in, you might have 2, 3, 4, 5, 6, 7, 8, 9 echelons. And the key MEI question is, how can we position our safety stocks such that the overall safety stock is the lowest? So in the entire network, the safety stock is the lowest possible. And the customer service, as it pertains to my customer, is not jeopardized. So customer, if they want 95% service, we are still giving them that service. So let us look at this in a simplified picture. Here is a fictitious network where we have some production, then some movement of products, distribution. It reaches a DC that takes about 8 weeks, and that DC then moves it further to some regional DCs, and that takes about 3 days. Now the question I would like to take a few seconds on is, in this example, what happens if there is no safety stock at this EDC? Well, what will happen in that case is when RDC places an order, sometimes the EDC will have the products, sometimes they don't. Remember, no safety stock means 50% service level. So every 1 in 2 tries, on average, there will be no safety stock, no product. There will be a stock out. And if that's the case that is going on, then RDC will have to wait for EDC to get the product from the production source. So in effect, this 3 days lead time will get longer if this EDC is not holding any safety stock whatsoever. On the other hand, if this EDC is carrying tons of safety stock, then whenever the RDC orders, it will always be available. In a way, the 3 days might shrink a little bit, but certainly, more importantly, I should say, the variability around that lead time will go away. So that's a key question to understand. What happens in the multi-echelon environment if nodes prior to a node do not carry inventory? Well, the lead time gets longer, or the variability gets longer or shorter, depending on how they carry the inventory. Once you understand that, the idea of multi-echelon is very simple. What do the customer want? Well, these days, customers want shorter and shorter lead times. So, I'm sure you've heard of Amazon opening warehouses in every store because they want to do the same day delivery. And, so this is a push towards shorter and shorter lead times. This is true in B2C, this is true in B2B. The single echelon way of thinking, if you have done the coursework there, would say centralize as much as possible because let's avoid the risk. Let's not push the product to Kansas. Let's keep it in the central warehouse so that if the demand actually happens to come from New Jersey, we can push it in that direction. So keeping the stock centrally allows us to pool the risks. Same thinking can also go into the idea of postponement. Don't put it in bottles and cans and drums. Keep it in bulk so that we can delay putting it into these different packaging and therefore minimize the risk. The issue is, of course, this is all fantastic if your customer is willing to wait. So if you keep the product in the central DC and only push it out at the very last minute, the customer will have to wait some extra time to get the product. If they are willing to do that, this is fine. But these days, like I said earlier, this is simply not the case. Customers want it today. So the single echelon principle of rest pooling, reduced to its simplest terms, simply says centralize as much as you can. And there is a formula, we call it the square root of n formula. So if you have only one warehouse, a central warehouse, well, compared to 2 warehouses, it will have 29% less inventory. Compared to 4 warehouses, it will have 50% less inventory, and so on. So it becomes very obvious, if your customers are willing to wait, the best thing to do is to just have one humongous warehouse. Unfortunately, that way of thinking in the single echelon, where either it's n decentral warehouses or one central warehouse, that question, when we ask in the single echelon way, the principle of risk pooling simply leads to the centralized one warehouse. However, the multi-echelon thinking is no different. It's also related to risk pooling, and it's originating from the same thought. However, it concludes things differently. What it's first and foremost worried about is centralization is simply not always an option because customers are so demanding, They want short lead times. If you want to have short lead time, centralization is no longer an option. And so now if you agree with that premise, then you have a multi-echelon network, you have multiple steps. The question then becomes how best to distribute the safety stock within this more complex multi-echelon network. Well, when we risk pool in the multi-echelon way of thinking, the conclusion then tends to be that if everything had to be pooled across all the locations, if we take a very simple example, one central warehouse and 4 non-central warehouses, then if we want to put it centralized, then everything goes to the middle warehouse, the central warehouse. If we put it across all the points, then we have 5 points. And if you try to optimize it, very often multi-echelon way of thinking says, well, it's best to keep the safety stock closest to the customer so that we can give it to them as quickly as possible and not have a whole lot of safety stock in the central warehouse. So the risk pooling in a multi-echelon network leads to very similar conclusions based on very similar theories, but instead of putting everything in the central warehouse, which the single echelon way would do, it actually pushes the inventory closer to the customer. So in this example, in the schematic, you can see the safety stock in the middle, the central warehouse goes to 0 in this picture, but the safety stock in all the forward warehouses increases. It might sound counterintuitive, but doing it that way in the multi-echelon framework actually increases the overall profitability. The safety stock actually goes down by up to 30%. Some cause and effect around safety stocks. Most networks, because of this pull from the customer to have the product now, they feel a magnetic pull for the safety stock to be positioned closer to the customer. Factors that affect that, things like long lead times, high customer service level demands, differentiated customer service level demands, variability in the demand. All these are factors that basically push the safety stock closer and closer and closer to the customer. Every once in a while, you do see counter forces that pull the safety stock upstream. So let's look at a few examples. If your product, for example, becomes very expensive, the product value goes up significantly as it gets closer and closer to the customer, well, that will then provide a signal to your supply chain to keep the product inventory further upstream, further away from the customer. Likewise, if your inventory carrying cost, if your demand happens to be all in North America, inventory carrying cost here is way more than inventory carrying cost, let's say somewhere else, well, then again, you might be, the signal from your supply chain might be to keep the inventory away from the customer as much as possible. If you have bottlenecks and other constraints, again, it might have a tendency to pull the safety stock further upstream or further away from the customers. All right, so let's do a quick wrap up. We have looked at the single echelon safety stock methodology, and we just kind of briefly introduced the multi-echelon methodology. The key idea that I would like to take away from today is once you have done the policy setting, which we talked about in the first webinar, safety stock targets are the next big area of opportunity, and whether you do it in the single or the multi-echelon way, you can create a lot of value by doing your safety stocks properly. So with that, I'll turn it back over to Helen.
Thanks, Ajit. I think that was a very insightful discussion. I think we're equipped with some tidbits and things to look at when it comes to inventory optimization. And what's very exciting is the fact that our solution is equipped with the features to be able to do this. So if you are interested in seeing a demo, you can simply visit our website or you can contact me. So since this is the second part of our webinar series, I also wanted to mention that we are going to have the third part, which will focus more on inventory planning and supply planning and how that factors into your inventory strategies. We had the first webinar which focused on policy setting, so you can also check that out as well. It's on our website. We're going to be taking, we just have a few minutes left, so we will have some time for questions. If you have some questions, you can just put it in GoToWebinar at this time. so it looks like we have one question from Jenna. Jenna wants to know, Sajid, how do you measure forecast accuracy?
Great question. I think we did a few blog posts on this. We will be happy to share. But in general, the most commonly used forecast accuracy measure is the percent error, also known as MAPE, or mean absolute percent error. It has its obvious downsides and upsides. Again, we have a blog post on this. If you are a supply chain practitioner managing hundreds of products, you want to calculate the MAPE of every single one of them separately. On the other hand, if you are reporting this metric to your management, MAPE seems to be a type of metric that actually wipes away some of the positives and the negatives, and at a very high level, it appears to give a very rosy picture. So in that sense, if you're reporting this not product by product, but as a global number, the way to measure it is via the use of WMAPE, or the weighted MAPE, and that would be my recommendation. Again, we have a blog post on this as well. So if you were to share your I suppose we already have that. We will be happy to send you the link to the blog posts around this, and hopefully that answers the question about how to measure forecast accuracy.
Okay. All right, thanks. So we have another question from Joe. Joe wants to know, so when you're getting started, you're looking at your entire network, trying to figure out what strategy to go with. What would you recommend? How do you even get started?
I always recommend starting slow, and if you look at today's presentation, we talked about single and then multi. There's a reason for it. Even to do single echelon calculations, there's a lot of data requirements. There's a lot of process requirements for that to be effective. So I always recommend companies of a reasonable size to start from the single echelon way of thinking. Actually, I should say, even before you get to single echelon, I suggest that they look at the policies that we talked about in the first webinar. But as far as this topic is concerned, if you have the policies and so on in place, then you look at the single echelon, and then you slowly move towards the multi-echelon. Typically, it's about at least a 3-year journey before you are ready to do any kind of multi-echelon thinking.
Okay, great, thanks. So I believe Jenna wanted to also know if you can get a copy of her presentation. We will send the recording at the end of the presentation, so you have access to that as well. And so we just want to thank everybody for taking the time today to just talk about inventory and what we're doing. And if you have any questions, feel free to reach back out to us at any point in time.